we're just going to prove how these identities, the ones on the bottom corner of the green sheet, how they exist. If this part of the notes confuses you, please don't feel bad about that. It is a little confusing proving things. You can just disregard as long as you don't mind not knowing how something happened, as long as you understand how to use the ones that are on the green sheet. So this says, first we're going to prove the 3 different Pythagorean identities using a reference right triangle in quadrant 1 of the unit circle. This will give you a strong foundation of why the identities are what they are and will help you when working problems that need to use any of these 3 identities. So here we're going to make our reference triangle. We have a vertex in the middle. Here's our ray, and then we're going to connect down to the axis. Our angle is theta. Our distance here is y because it's vertical. Our distance here is x because it is horizontal. And then our radius is 1 because we're on the unit circle. And we're going to use, just like we did for all of our other reference triangles, a squared plus b squared equals c squared because we're using a right triangle. Now, we don't have a location at all. We do obviously know x and y, so we can plug those in if we wanted to. We would have x squared plus y squared equals 1 squared, which is just 1. But if we want this to be an identity, if you notice all of our other identities in the reciprocal box or the quotient box, they all have a trig function on them. So we want to write this in terms of trig. We know, according to our ratios, that the sine is the same as the y value, and that the cosine is the same as the x value. So instead of writing x, I could write the cosine of our angle. And instead of writing y, I could write the sine of our angle. And now this is written in terms of trig, and this would be P1. Good, that is what's written on here on our green sheet under P1. I did put sine first on the green sheet, not sure why, but sine plus cosine, cosine plus sine, because they're being added and both are positive. It doesn't make a difference which order you put them in. It would matter if one of them was negative. And we're also going to see the other 2 ways we could write each of these. So right now we know what is equal to 1. We could also find out what's equal to cosine squared and what's equal to sine squared by just rearranging the equation, kind of like you do in chemistry. So if I want to get cosine by itself, I could move this sign over here to the other side of the equal sign. Because it's positive, I would subtract it from the 1. So it would look like this. I could do the same thing for sine. If I want to get sine by itself, I would move the cosine over to the other side. It's positive, so I would subtract it from the 1. And it would look like this. So all 3 of these are P1. You'll notice they all have the same values. They're just in different orders. And all 3 of those are also written here on your green paper next to P1. I don't want you to memorize. I just want you to be able to look at it and identify where we are on the green page. Now, there are 2 camps of teachers. One camp believes in only teaching P1 and then making all of your other problems. You would just change them all to cosine and sine, just like we've been doing. It's just going to be a wild amount of more steps to do that if you don't just do P2 and P3. So I personally fall into the I teach all of them camp, which is why they're all in here. It's much faster if you use P2 and P3 as well. So to find those, we're going to derive them. That means we're going to find them by multiplying, dividing, subtracting, whatever. So we're going to rewrite P1. And then to find P2, we will divide by cosine. And our goal here, right, is to find the other trig function. So right now we have cosine and sine. We need to find the other 4 in terms of this reference triangle. So I'm going to divide everything by cosine. I'm going to write it over here, kind of just written out so you can see that it's dividing by each one. it would look like. And then obviously remember our goal is getting to the other 4 trig functions. This doesn't have them yet, but if we were to simplify, we'd be able to find 2 more. So I look at the first part here. This is cosine squared divided by cosine squared. Anything divided by itself is 1. If I look at the next one, I have sine divided by cosine. According to my green sheet, that is the same as Q1. Q1 tells us that sine over cosine is equivalent to tangent. And because those are squared, my tangent would be squared. And then over here, I have 1 divided by cosine squared. According to R5, there, 1 over cosine is equivalent to secant. Because that cosine is squared, our secant will also be squared. And this is P2. So I found 2 more of the functions. I now have seen cosine, sine, and now tangent and secant. So we're just missing cosecant and cotangent. We're also going to write the other 2 ways you could write this. So right now we are equal to secant squared. We also want to be equal to 1 and equal to tangent squared. So we're just going to rearrange to be equal to those as well. All 3 of these forms are on our green sheet under P2. Excuse me. So if I want to get 1 by itself, I would move this tangent over to this side. It's positive, so I would subtract it from the secant squared. And it would look like that. And then to get tangent by itself, I would move the 1. It's a positive 1, so I would subtract it from the secant squared, and that would get tangent by itself. And there are 3 forms. Now we'll do the same thing to derive P3. So here, instead of dividing by cosine, we will divide P1 by sine. And that should get us our last 2 trig functions. So now I'm just going to separate it out like I did on the last one, just so we can see what we're doing a little easier. And then we're going to simplify. Remember, our goal is getting our last 2 trig functions. This first one, cosine divided by sine, according to our green sheet, is Q2. Cosine over sine is cotangent. If those are squared, our cotangent will be squared. The next one, we have sine divided by sine. Anything divided by itself is 1. And then lastly, we have 1 divided by sine. According to R4, 1 over sine is equivalent to cosecant. Since our sine is squared, our cosecant will also be squared. Here is P3. Now we're going to rearrange to be equivalent to the other 2. So right now we know what's equal to cosecant squared. We also want to know what's equal to cotangent squared and what's equal to 1. So to do cotangent, we would just move the 1 over. It's positive, so we would subtract it. And then to do 1 by itself, we would move the cotangent over. It is also positive, so we would also subtract it. And there we go. All 3 of these are at the bottom of your green sheet next to P3. Specifically, please don't try to memorize anything. I just want you to be able to see them by sight and match them to the green paper. You'll be allowed to use the green paper on your final. I will give you a different, they'll be the same thing. Okay, I'm gonna back up. This was honestly kind of pre-AP-ish. We just derived how we got the 3 P's. Like I said earlier, if this part you were like, I have no idea what's going on this whole time, totally valid. You don't have to know how we got them. I just wanted you to see, just in case your brain works like my brain needs to know why something is happening. So just in case anyone else is like me, that's why we're doing it. If this page again confused you, don't worry about it. Just take them off here. Let's look at some questions. This says practice using the derived identities, so P1, P2, P3. You will notice that all of our Pythagorean identities include the trig functions squared, let's underline that, and all the reciprocal quotient identities do not have squared functions. They don't start squared on here, but as you saw last time on our worksheet, they can be squared, they just don't have to be squared. For the Pythagorean ones, they have to be squared. They don't work if they're not squared because part of the identity is it being squared. That's what they mean by that part. This is something to note when working on problems to help you decide what steps to do to simplify. Please also pay close attention to parentheses and other operations in the problem. I want you to underline the words other operations. And put an arrow. To be able to use a Pythagorean identity, it has to have a plus or a minus sign. It cannot be used if everything is being multiplied. So what we've seen so far in our previous practices, when using reciprocal and quotient, it's always been completely multiplied, right? Remember, we didn't see plus or minus, we just stuck in dots. For these, you have to have a plus or a minus to be able to do anything with a Pythagorean identity. So we're going to say must have plus or minus and trig squared. So 2 things you have to have. It has to be squared and you have to have a plus or a minus. Okay, let's give it a go. On this page, I made these a little easier because I know these are introduction ones by telling you what we're going to have to do. Like on this side here, that tells us what we're going to do. Obviously on the Delta Math practice, it'll just give you the question like this and you'll have to simplify. But the Delta Math is multiple choice, so that does make it a little bit easier, I think. Let's look at the first one. This one I'm telling you we have to simplify by factoring. And here is our question. I know I'm going to use a Pythagorean identity because I have a plus sign and something squared. What I'm going to do now is see if I can make it look anything like what I have here. I can only use these if what I have on my paper matches the green sheet. So I'm look and see what I have squared. I see I have a cotangent squared. So looking at your green sheet, if I have cotangent squared, am I going to use P1, P2, or P3? P3, good. P3 is the one that has cotangent. I'm not going to put it there yet. So if I wrote it here now, it wouldn't really make sense because I can't plug it in yet. I'm going to wait until I have one of these formats here on my green sheet. So I either need 1 plus cotangent squared, cosecant squared minus 1, or cosecant squared minus cotangent squared. I don't have any of those. So let's see. I told you to factor. What we're going to do is take out a greatest common factor. You'll notice this term and this term, they both have a sign in common. So I could take that sign out the front by dividing it out. So I'm going to put over here GCF sine of theta. You didn't think factoring was coming back? Here it is. It's going to be there forever. Okay, so I'm going to put out front sine of theta. Now I'm going to divide it out of both my terms. If you want to draw, if this would help you, can draw it over here too if you want to see it written down. Sine divided by sine is 1. And I have a plus sign. Sine cotangent squared divided by sine. The signs are going to cancel, and I'll only have cotangent squared left. Now I'm going to reevaluate. I know I'm going to use P3, so now we're going to look at P3. Do I match any of the options now with 1 plus cotangent squared? Yeah, I do right. On my green sheet it says 1 plus cotangent squared equals cosecant squared. So I can use P3 now, so now I'm going to write it down. P3. I'm going to highlight. And instead of writing 1 plus cotangent squared, according to my green sheet, it's equivalent to cosecant squared. That's what I got now. And our goal, I didn't put it in the directions, but our goal for all of these, at least for our class, is to always get down to one trig function or a whole number, just like on our notes for reciprocal and quotient. So we're always going to go all the way down to one function in the numerator or a single number. So we're getting closer, right? We started off with 2 full terms and 3 trig functions. Now we're down to just 2 trig functions that are technically one term because they're being multiplied. Now I no longer have a plus or a minus. Remember, to be able to use a Pythagorean identity, I have to have a plus or minus. I don't have any more plus or minuses, so I can't use any more of them. If I want to try to simplify this, I need to use either reciprocals or quotient identities. I do know, remember back last week when we did these, if I had something that wasn't sine or cosine, I'm going to change it into sine or cosine if I'm not going to use a Pythagorean identity. So let's see if we can change this cosecant. According to our green sheet, what am I going to use? Which reciprocal identity can I use to change cosecant into sine or cosine? R4, good. R4 tells me that cosecant is equal to 1 over sine. So cosecant squared will be equal to 1 over sine squared. I'm still multiplying by this sign on the outside. That GCF has just been brought down every time. Now, I know that this is in the numerator because it doesn't have a numerator. So if this is in the numerator and these are in the denominator, can I cancel anything out? Good. I have 1 on top and 2 on the bottom, so I can cancel 1 from each, and I'll be left over with 1 on the bottom. So I'm going to cancel this one, and I'm just going to cross out the squared there because I still have a sign in the bottom. Now that will leave me with, 1 times 1 over sine, which would just be 1 over sine. And we're almost done. Remember, our goal is to get down to 1 trig function that's in the numerator. So I'm going to look now. I have 1 over sine. I just used it, right? I just used R4 that said that cosecant is equal to 1 over sine. So if I do R4 again, this feels silly, I know, I will get to cosecant. And now I have 1 trig identity in the numerator, and that would be the answer. That felt long, but that was actually only 4 steps. There we go. Here's the whole question. So general summary, our goal is to get to 1 trig function or a number by doing any kind of simplifying that makes sense mathematically. I start and I look for a plus or minus. If I have a plus or minus, I have to use a Pythagorean identity first. Well, or second, but I have to use one. So I have a plus, so I'm going to say, okay, what could I do? I saw that I had cotangent squared, so I looked at my green sheet and identified I would need to use P3, but it didn't match anything yet. So I tried to simplify. I did that by taking out my sign, and then it matched. So I was able to apply P3, and that got me to here. And then I didn't have any more plus or minuses left, so I had to use a different kind of identity. I figured out if I simplify, I change everything to sine and cosine. So I changed this to sine, and that let me cross it out. And then I reverted back because my answer needed to be 1 trig function in the numerator. So biggest problem people normally have is just figuring out how to start it. Hopefully that will come with time. Let's try another one. This one looks very similar. You'll notice this second one here says simplify by distributing. So this time, instead of starting with it already multiplied, we're going to have to multiply. And the reason we're doing that, if you look at our question, we do have a minus sign, but we don't have anything squared. Remember, to be able to use a Pythagorean identity, we have to have a plus or a minus and something has to be squared. So if I were to re-multiply this, that would get me a sine squared. So let's do that. So I have sine times cosecant, would just be sine cosecant, minus sine times sine is sine squared. Remember, our sine is squared, not the theta. So it looks like that. now I'm closer. I have a minus sign and a squared. And specifically, I have a sine squared. So let's look at our green sheet. Am I going to use P1, P2, or P3? Looking at our green sheet, not me. Where we have sine squared. Which one is P1, P2, or P3?
P1.
P1. Good. P1 has sine squared and cosine squared. Now here, I just have minus sine squared. This front number is not a 1, so it doesn't match anything on my paper yet. So I need to figure out how to make this look like what's on my green sheet. I could see if I could simplify something here, because obviously this part is already correct. I don't want to change that. So here, these are being multiplied. So I would use a reciprocal identity. And I do happen to know from all of my practice that these are reciprocals. So let's see if I could cancel anything. So I have my sine times my cosecant. If I change my cosecant into sine and cosine, I should be able to simplify. And I know that that is R4 because I used that like 3 times in the last question. So R4 tells me that cosecant is 1 over sine. Excuse me. I'm actually going to leave this the same because that has not been messed with yet. Now, can I do anything here? What can I do here? If it helps, I can tell you I have a sign on the top and a sign on the bottom. What could I do with those signs? Anyone can answer. I could cancel. Good, these will cancel out to make 1. So that would leave me with 1. And then I still have my minus sine squared. Now I'm going to go back to my green sheet. I already said I was looking at P1. Now I do match. If you look at your green sheet, P1, I have 1 minus sine squared is equal to cosine squared. So I can apply P1. I'm going to put it right here, P1. P1 tells me that 1 minus sine squared is equal to cosine squared. Cosine squared is one trig function, so that would be our answer. Okay, let's look at these. The next 3 are similar. Well, actually, this one's more similar to these two. These 2 are similar. So looking at this next one here, if you look at the numerator, that does look like the last 2, well, really the first question. It looks really similar to this one. So go ahead and see if you can simplify that numerator. You're going to keep the denominator the same. So looking back on number 1, see if you can apply what we did here to the numerator of this one. Okay, we said that the top matches this one. So you would take out a GCF. What do these 2 terms have in common? A sign. Good. Let me take a sign out. Put it out front. And then we just divide everything by sign. So that'd be 1 minus cosine squared. And this is where I'm at now. Now I have a 1, I have a minus, and I have a squared. So I'm going to look at my green sheet. I'm looking at cosine squared. So am I going to use P1, P2, or P3? P1. Good. According to my green sheet, P1 has cosine squared. And I already match. So according to my green sheet, I have 1 minus cosine squared. That's equivalent to sine squared. So I'm just going to rewrite it here. And I'm going to apply P1, so this is now a sine squared. My goal is to get down to just one trig function. Looking at my fraction, is there anything I can cancel? Yeah, I have 3 signs on top, 2 on the bottom, so I can cancel out 2 of them, and that will leave me with 1 up on top. So I'm just going to cancel out these 2 right there. And that leaves me with just a sine of x on the top, or just sine x. Okay, good. Let's look at this one. This one is still similar in that you will take out a greatest common factor, but this time it's going to be a number instead of a function. So if we look at the numerator here, this does not have a plus or minus sign or anything squared, so I can't do anything with the numerator yet. So I'm just going to write it up here. Then I'm going to look at the denominator. The denominator does have a plus or minus, and it has 2 squared, so I am going to look at my p's. I have sine squared and cosine squared, which according to my paper is P1. So look over here, and I want to see if I can apply P1. That means, does what I have on my green paper look exactly like what I have in my question? So on my green paper, I have sine squared plus cosine squared. I have 1 minus cosine squared, or I have 1 minus sine squared. This doesn't match any of those. It is close to the first one, which again is sine squared plus cosine squared. You'll notice I have a negative and a negative. I need them to be positive. So if I need to get a positive number, I'm just going to divide out a negative 1, like this. So if I take out a negative 1, that just changes the sign of everything, because a negative divided by a negative is positive. Same thing for that cosine. This negative divided by a negative is a positive. And now, inside my parentheses, it does match the green paper. It has sine squared plus cosine squared, which according to my green sheet is equal to 1. So now I can apply my Pythagorean identity. I'm on P1. And P1 says that instead of saying sine squared plus cosine squared, I can say 1. Okay, now I'm just going to simplify this. I have a negative tangent on top and a negative 1 times 1 on the bottom. That would just be negative 1 on the bottom. Tangent over negative 1. And then lastly, a negative divided by a negative is a positive. So my answer is just tangent of theta. This question I actually took from your Delta Math practice, so this is going to look really similar to what you're going to see on your practice today. Okay, I'm going to back a little bit. So going back over to here, are there any questions on how I got from each step to the next step? That's going to be obviously my concern for confusion. What about this one? Any questions how I got from each step to the next step? Okay. Biggest takeaway, if it looks really similar to what's on the green sheet, but it just is in the wrong order or has the wrong sign, you are 98% of the time going to take out a negative 1, so just try that first. Okay. Go ahead and try this one. I'm going to give you a hint. You're going to have to rearrange the bottom and take out a negative 1. For 3 minutes, so we'll see what we got. Looking in my numerator, I have a subtraction and 2 squared, so I'm going to use the Pythagorean theorem identity. So I'm looking over here at my green sheet. I'm looking for P1, P2, P3. I have a secant squared, so I'm going to use P2. That's what my green sheet says. Now I'm going to match and see if it already matches my green sheet or if I need to rearrange. It says secant squared minus tangent squared. So I'm going to look at my green sheet, and I do in fact have secant squared minus tangent squared. That's equal to 1. So I'm going to put P2 because I'm going to use it right now. And instead of putting secant squared minus tangent squared, my green sheet says that it's equivalent to 1, so I'm just going to put 1. Now I'm going to check my denominator. I have a subtraction sign and a square. So I'm going to use a Pythagorean identity on the bottom as well. I have cosine squared minus 1. So I'm going to look over here. According to my paper, cosine squared is P1. Now, if I look at P1, I have sine plus cosine equals 1. I have sine equals 1 minus cosine, and I have cosine equals 1 minus sine. None of those match what I have on my paper, but it's really close to the second one. The second one, I need to have 1 minus cosine squared, and I have cosine squared minus 1. So I'm just in the wrong order, so I'm just going to flip it. So instead of saying cosine squared first, I'm going to put the 1 first. But you'll notice that 1 is negative, so I'll move my negative 1 to the front, and then my cosine to the back. That cosine is positive, so it will look like this when you flip it around. Now it looks close still, but it's still not exact. I need to have a positive 1 and a negative cosine squared. Anytime you have to rearrange, remember we mentioned it earlier, and the signs are wrong, you're always just going to take out a negative 1. So I take a negative 1 out. There we go. Negative 1 divided by negative 1 is positive 1. Positive cosine squared divided by negative 1 is negative cosine squared. So remember, what we do when we divide by a negative 1 is we're just changing the signs. Now I match on the green paper. According to my green sheet, P1 is sine squared equals 1 minus cosine squared. And I have 1 minus cosine squared, so I'm going to use P1. And instead of saying 1 minus cosine squared, I'm going to say sine squared. Now, I don't have any more plus or minuses, so I can't use any more p's, but I do still need to get down to one trig function in the numerator. So I'm going to look at my q's and my r's. I have 1 over sine, so I'm looking over here for 1 over sine. I have that on R4. R4 tells me that 1 over sine is equal to cosecant. So if I have sine squared, then it's just going to be cosecant squared. And then here it is negative, so it's going to be negative cosecant squared. So I'm going to go back a little bit so you can see the whole thing. Again, general summary. You look to see if you're going to use a p, if it matches, if it does, apply. If it doesn't match, rearrange until it can apply. So for this one, we originally had to switch places, and then we said, well, we have the wrong sign, so we had to change the sign as well. If you realized before you did it that you had to change the sign and switch, you could put these 2 steps into one if you wanted to. That's okay as well. And then the last one here, I originally put this here to just show you guys how complicated it could be if we didn't use P2 and P3, but I don't really think that's super valuable. So we're going to ignore those directions, and we're just going to plug in. This one I also took off of the delta math that you're going to do. So in the numerator, I have 1 minus cosine squared. So I have a minus and a squared, so I'm going to look at my green sheet. Cosine squared is on P1, and it already matches, so I can apply it from the start. According to my green sheet, 1 minus cosine squared is sine squared. And then in my denominator, I have cosecant squared minus cotangent squared, so I have a minus sign and some squareds. So I'm going to look over my green sheet, and I have P3 has cotangent and cosecant. And I'm just going to look and see if I can match my green paper. I need 1 plus cotangent squared. I don't have that. I need cosecant squared minus 1. Don't have that. But I do have cosecant squared minus cotangent squared, which is equivalent to 1. So I can just apply my P3 from the start. And then obviously sine divided by 1 is just sine.